Alex and Amy are currently on holiday in Egypt. It was on their bucket list of places to go because of the Egyptian pyramids. Egypt is a country linking Northeast Africa and the Middle East together. Alex and Amy knew that a defining symbol of Egypt was the Great Pyramid, which was built around the years of 2550 BCE. Alex knows a lot about the Egyptian pyramids, so he will be helping us and Amy learn more about them. Amy couldn't believe the pyramids were as big as what they were. She couldn't understand how they were man-made thousands of years ago, when they never had the technology to help them. Alex then explains that it is believed the pyramids were constructed as a tomb for the kings. To build the pyramids, the Egyptians constructed wet sand blocks, and to move the stones over the land, Egyptians used large sledges that could be pushed or pulled. Alex explains that the pyramids are a geometric shape that many students study in school. Geometry is a word which can be broken into two, geo meaning earth and metry meaning to measure. It is defined as a mathematical study of shapes, size and position which can either be two-dimensional or three-dimensional. Two-dimensional objects only have two dimensions, length and width, whereas three-dimensional objects had a third dimension, depth, meaning that they are not flat. Euclidean geometry is a study of geometry based on definitions, assumptions and the terms of the mathematician Euclid. Euclidean geometry can be explained on a flat surface through the use of 5 postulates. The first postulate is, through any 2 points there is exactly one line. The second is, through any 3 points that is not on the same line, there is exactly one plane. Third, a line contains at least 2 points. Fourth, all right angles are congruent. Fifth, given a line and a point not on the line, there is exactly one line through the point that is parallel to the given line. Non-Euclidean geometry is a consistent system of definitions, assumptions, and proofs that describe such objects as points, lines, and planes. So these pyramids are three-dimensional shapes, all solids with a base and triangular faces, that meet at a point called a vertex. Alex then begins to explain that another mathematical term, known as the golden ratio, was suspected to be used in the construction of the pyramids. A golden ratio pyramid is based on a triangle whose 3 sides represent the mathematical relationship that defines the golden ratio. This triangle is known as a Kepler triangle. It has a base length of 1 and a hypotenuse whose length is phi, 1.61803399. The height of this right triangle is the square root of phi, so the height of this right angle is the square root of phi. Cross-section in the pyramid produces a right-angle triangle. If we take estimated dimensions from reliable researchers, we are able to see if this pyramid indeed used a golden ratio. The height of the Great Pyramid averaged at 146.51 metres, and the base at 230.36 metres. Half of the base is 115.182 metres. Using Pythagoras' theorem, 146.51 metres squared plus 115.182 metres squared equals 186.369 metres. Dividing 186.369 metres by the base looks like this. 186.369 metres divide 115.182 metres, which will equal 1.61803, which is exactly phi to 5 decimal places. Another mathematical concept that relates to the geometric design of the Egyptian pyramid is pi. Pi makes the height of the pyramid equal to the radius of the circle that has a circumference equal to the perimeter of the base of the pyramids. The average length of the side of the Great Pyramid of Giza is 230.36 metres, and the height 146.51 metres. The way pi is incorporated within the Great Pyramid is length plus width divided by height equals pi. So 230.36 metres plus 230.36 metres divided by 146.51 metres equals 3.14464. That number is 99.903% of the real number of pi. Pi is now used in modern day geometry. Amy can't believe the mathematics that went behind these pyramids. She never would have thought they would be built the way they are, and wondered if the Egyptians knew the extent of the maths they were using. She thanks Alex for being kind enough to let us all know about this information, and she can't wait to go on their next adventure and have a look at other structures which have other mathematical geometric aspects.